In this closer look, we'll focus on converting from moles to volume. As a reminder, a mole is a really big number, 6.02 times 10 to the 23rd to be exact. Molar volume is the volume occupied by 1 mole of a substance at a given temperature and pressure. Standard temperature and pressure, or STP for short, refers to the conditions of 1 atmosphere pressure and 0 degrees Celsius. Under these conditions, 1 mole of any gas will occupy 22.41 liters. So as long as the gas is at STP, remember that's standard temperature and pressure, a mole of any gas will always be equal to 22.41 liters. And this is the equivalent statement that is the conversion factor in molar volume problems. The conversion factor will be 1 mole of any gas in the denominator and 22.41 liters in the numerator. And again, this conversion factor is used to go from moles of a gas at STP to volume in liters. Here's a practice problem using gas stoichiometry with molar volumes of gases. The equation for the combustion of methane is 1 mole of methane plus 2 moles of oxygen yields 2 moles of water plus 1 mole of carbon dioxide. Now, if 2.5 moles of methane at standard temperature and pressure are burned, what volume of water vapor will be produced? So if you remember using a conversion chart for other problems, you'll use it here too. Start solving this problem by putting what is given in the upper left-hand corner of a conversion chart. So 2.5 moles of methane is the starting point, and now set up the conversion chart. Then bring down the units of moles of methane in the denominator of the second column. And you can go right to the mole ratio step since you already have moles. And then go from moles of methane to moles of water vapor. Based on the balanced equation, there is 1 mole of methane that is used up for every 2 moles of water that are produced. And you can cancel units of moles of methane because they appear in both the numerator and the denominator. The next step involves converting from moles of water to liters of water, because that's what the question asked for. And this is where it's very important to recognize that the substances are at STP, because a mole of any gas at STP is equal to 22.41 liters. And you can cancel the units of moles of water here and here, so you have liters of water in the upper right-hand corner. Since the question asked what volume of water vapor would be produced, you know you're done with the converting part. So you just multiply 2.5 times 2 times 22.41 liters, and then divide that by 1 times 1, which is, of course, 1. The result is 112, or when you round for significant figures, 110 liters of water vapor are produced when 2.5 moles of methane are combusted under the conditions of standard temperature and pressure. This next problem also involves the combustion reaction of methane with oxygen to produce water vapor and carbon dioxide. This question asks to solve for the volume of carbon dioxide if 14.3 moles of methane, again at STP, are burned. So take what's given in the problem, in this case 14.3 moles of methane, and put that in the upper left-hand corner of a conversion chart. Bring the units down, in this case moles of methane, and in this problem we want to get from moles of methane to moles of carbon dioxide. And notice in the balanced equation there's an understood 1 in front of methane and an understood 1 in front of carbon dioxide, so you put a 1 here and here. The units for methane cancel, and since the system is at STP, bring the units of moles of carbon dioxide down here, and you know that 1 mole of carbon dioxide will occupy 22.41 liters. Again, the units of moles of carbon dioxide will cancel, and now just multiply 14.3 times 1 times 22.41 and divide that by 1 times 1, or in other words 1. And when you multiply 14.3 times 1 times 22.41, you find that 3.20 times 10 to the second liters of carbon dioxide are produced when 14.3 moles of methane are burned under the conditions of STP. Here's a mole to volume problem for you to try. Let's keep using the combustion of methane equation. The question asks, if 3.8 moles of methane at STP are burned, what volume of oxygen will be required for the reaction to go to completion? When you're ready, press pause and try the problem on your own, and when you've finished, press play and check your work. Now let's see how you did. Your work should look similar to this. You started with 3.8 moles of methane, then brought the units down, moles of methane, and in this first step you converted from moles of methane to moles of oxygen. There is an understood 1 in front of methane in the balanced chemical equation, and there is a 2 as a coefficient in front of oxygen. That's where the 1 and the 2 came from that you put here and here. And then you brought the units of moles of oxygen down. Since the question is asking what volume of oxygen will be required, and it's at STP, use the equivalent statement, 1 mole of oxygen equals 22.41 liters, to convert from moles of oxygen to liters of oxygen. The next step was to multiply 3.8 times 2 times 22.41. And if you found that the volume of oxygen that would be required is 170 liters when 3.8 moles of methane react, you got it right. That's a closer look at converting moles to volume. For more chemistry matters, go to our homepage where the entire series is available to you.